Hey guys, welcome. We're going to get started here on the 7 review. So we're starting out with some nice easy little proportions here. And so we're going to cross multiply to solve these. We're going to get 3x equals 30, which means x equals 10 right there. I'm going to go ahead and come down here. 3 times 7 is 21 equals 2x plus 2. Make sure we distribute, and that is going to be a 4. Because 2 times 2 is not 2, it's 4. Subtract the 4 over, and this is when you're like, Mr. Smith, after that little guy, you better be using your calculator so you don't make a mistake. Then we get 17 equals 2x, and divide by 2, x is going to equal, and you'll notice there's going to be fractions and decimals all the time. 8.5. Cross multiply over here, 4 times 6 is 24 equals 12x, so x is going to equal 2. And then here, cross multiply, we get 4x equals, that's going to be 24x. And I think that's 60, but always better to double check. And so I'm going to move this over here. We'll end up with a negative, that's okay. So it's going to become negative 20x equals negative 60. Divide two negatives, make a positive. And so that's going to become positive 3. Cool thing is you can always plug these back in and double check. Like 12 over 3, that's just 4. That's 6 minus 5, which is 1. And 4 over 1 is 4 as well. So you can kind of just do it that way as well. Two complementary angles are in the ratio of 7 to 11. What's the measure of the smaller angle? So when we're doing these extended ratios, this is not that extended, but we're doing it extended. It's complementary, which means we know they add to 90. And so the two unknowns are x and x, but we get to put the ratio values in front of them. So it's 7x plus 11x equals 90. So we get 18x equals 90. And 18 is going to go into 90 about 5 times. But it did ask for the measure of the smaller angle. So we're going to take the smaller one, which is 7, multiply by 5. And I believe that's going to be 35. It is. I just always double check. So we get 35 degrees for the angle, for the small angle. All right, I'm not going to do 7 or 9 because they're the challenge problems. They're a little bit more difficult, but what I'm going to do instead is the polygons are similar, and so I'm going to mark all of the corresponding sides that are congruent. And here it's pretty easy because I'm just going off of looks. Like, I can kind of tell that these are the matching sides. I have better angle measures to show, and it's going to be easy for me to set these up. Similar means sides are not congruent. It means that they are proportional. Okay, so the first thing I want to do is I want to identify a side that I have 2 numbers that are known. So 6, I have the green is known, the unshaded is not both known, the orange we actually know nothing, and the yellow we have 2 unknowns. So the best is going to be 12 over 4. I'm going to do big over small. And then I'm going to go to the uncolored one, and I'm going to go big to small, and I get y over 2. And we can set that up that way. So it's the greens kind of over the non-color. Cross multiply, we get 4y equals 24, and y is going to equal 6. Okay, because y equals 6, we can plug it back in here, and we get 6 times 3, which is 18, minus 2. This is actually now just 16. We can go ahead and get rid of that. Nice and easy. Okay, so 16. So now we can use this green setup again. 12 over 4, because we like having those numbers, equals, and now I'm going to use the yellow, and that's going to be 16 over z. So I compared the green again. We can use it more than once since I know them. I like it to the yellow. And the yellow works nicely because I know the y, and so I can find z pretty easily. And so we go ahead and cross multiply to get 12z equals 4 times 16, which is going to give you 64, and that's going to get divided by 12, which unfortunately isn't a pretty number, but z is going to equal 5.3 repeating. All right, last one is an angle measure. So an angle measure, they're congruent. So 3x should be equal to whatever this angle is. And since this is an exterior angle of 100, that means this interior angle is 80 degrees. So I just had to set 3x equal to 80 degrees here. And I'm going to take this space over here since we're not doing those problems anyways. 3x equals 80. And we're going to divide by 3. And this is unfortunately, again, not going to work out super even. But we're going to get x is equal to 26.6 repeating. All right, down here, this one is far more simplistic. But we have 8 and 5. Those are the two I know. We want to kind of try and use the ones we know. And then y is going to be in yellow, so we're going to do y over 2.5. Notice I went big to small, big to small. And we set those equal to each other. And cross multiply 5y equals 8 times 2.5 is 20. Divide by 5, y equals 4. Okay? And then x is so easy, I don't have to do anything. I just set it equal to what it already is. X equals 30. Angles are congruent in similar polygons. Okay? So there we go. Moving on. Prove the triangles are similar by angle, angle, side angle, side, or side, side, side. Okay. Well, let's do 11 real quick. We have two congruent angles. That is pretty apparent. And our similarity statement, I'm going to go one curve, two curve, no curve. That actually makes no sense. Let's go two curve, one curve, no curve. So two curve, one curve, no curve is similar to two curve, one curve, and no curve. Always a good way to do it. All right, this one's a little bit more challenging, so I'm going to draw them out separate. I do see they both share the C, so I'm going to go ahead and put that in there right away. And there we go. And this is going to be a side length of 12 and 21. This is going to be a side length of 20, and then this is going to be 35. So we have an angle already, so I'm leaning toward SAS. So let's go ahead and 12 to 21, so that's the small to the big, should be 20 over 35. Okay, so 12 over 20, that is reducible. I believe 4 goes into both, so that could become 3 over 5. Is that correct? I think so. And I think 7 goes into both, and that is also 3 over 5. So we have proportional sides and a congruent angle. So this is going to be SAS. So we're going to be able to say triangle QCT is similar to triangle, and I started with the bottom left and then went up, so I'm going to do the same thing, MCP by SAS. Similarity. Okay, just when I thought I was done, I'm not. I got more. Okay, so we have our congruent angle here. We just have to check those sides. And what I like to do is I like to go small to large, so 12 to 15, and then 16 to 24. All right, what number goes? 4 goes into both of that. That's 3 over 4. 15 over 24. 3 goes into both. 5 over 8. Not similar. Sorry, they don't work, but not similar. So that's all we have to do for that one. It doesn't go beyond that. Okay, so pretty easy on that one. Okay, this one, number 13, is a pretty trick problem. We have one angle here, but then we have a second angle here. So this is actually angle similarity, pretty tricky. So triangle ABC is similar to triangle. What matches with A? Well, E does. It shows you right there. And then what matches with B? Well, they share B, so B matches with B, and then D matches with C. And this is by angle similarity. That one that's pretty clutch. I like that one. Okay, we have 3 sides, so I'm going with this is either side, 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 or it's not going to work. We're going to go smallest to large, 4, 6, 7. And we're going to go small to large, 6, 9, and 10.5, and see if these can reduce. 4 over 6, I'm guessing 2 over 3. I'm guessing 2 over 3. And then 7 over 10.5. I don't know if that breaks down to anything good, but it does. It actually breaks down to 2 over 3. Because we could do 14, multiply by 2, 14, and multiply this by 2, we get 21. 14 and 21 are both divisible by 7, 2 and 3. So all three sides are the same ratio. So this is by side, side, side similarity. To make this easier for you, I would go ahead and just match up the short, all of these with your highlighter. Short with short, medium with medium, and large with large. It should make it a little easier writing your similarity statement. At least that's what I'm hoping. So I'm going to go X, Y, Z is similar to, so I got to look for orange and yellow. That's going to be a match with P. Orange and green is R. Green and yellow is Q. So colors always help me. Otherwise, I'd be in big trouble. All right. Just looking at this one, I'm thinking side angle side. I have two sides and I have an angle. I just got to make sure my sides are working. I have 8 and 10. So 8 goes with 10, and 4.8 goes with 6. Okay, this one's easier. It's going to break down to 5 over 3. This one's not as easy. 8 divided by 4.8. That one's tough. So this is what I would recommend to do is I'm thinking it should go into 5, so I'm going to multiply top and bottom by 5 and see if that gives me something. So multiply top and bottom by 5, that's going to be 40 over 4.8. That's 4.8. 4.8 times 5 is 24. Okay, and then I know 8 goes into 40 5 times, 8 goes into 24 3 times, so that does work. So we do have SAS. And so we're going to go HJK, the big triangle, similar to triangle RST. And that's by Sarsaparilla. Sarsaparilla. Okay, if you have like the teched out calculator like this, you can just do 8 divided by 4.8 and it automatically gives you 5 over a third. So this is really nice to have in that situation. Okay. All right, let's look here. Figure out the right, explain how you know AB is parallel to ED. This is because these triangles are similar. Look at twice, twice, and twice. So we have a scale factor of 2 to 1. So these triangles are similar by side, side, side similarity, which means that the corresponding angles are going to be congruent, and that means that if the angles are congruent, corresponding angles are congruent, alternate interior angles congruent. So if alternate are congruent, then we have parallel sides. Okay, so that's one of our converse theorems. It's the converse of alternate interiors. So if AIA are congruent, then parallel lines. Okay, and that's the converse of AIA. And we're able to prove the triangles are similar, which means they have congruent angles, which then we can prove this piece. All right, 7.5, find the value of x. So this is our side splitter, so we can just go really easily. 12 over 5, x over 6, breaks up into corresponding parts of these parallel lines. So we get 5x equals, that's going to be, I think, is that 72? I think so, it is. And divided by 5, which is going to give us a very unpretty number, but we get 14.4. This is the triangle angle, what is it? The triangle angle bisector theorem or something like that. Pretty nice little name. X over 6 equals 24 over 8, and we just cross multiply. We can reduce this because 24 over 8 is just 3 over 1. So that's going to save me a lot of math. That's just 18 equals x. Nice. Again, this to this, this to this, or this to that, that to that, doesn't really matter. I like to usually set it up the way it looks to me. And that's just like that. Cross multiply, we're going to get 21 times 40, relatively large number of 840. And we're going to get 2.1x squared. So we're going to divide this by 2.1, which I'm hoping that gives us something very convenient, which it does. We get 400 equals x squared. We can take the square root of 400, and big surprise here, we get x equals 20. Now, technically, when you square root a number, you're going to get a positive and a negative value, and my screen just went dark on me. Sorry about that. So usually we'll get a positive and negative number, but you can't have negative length, so negative 20 wouldn't make any sense. Okay, this one is a little trickier. And what I would do is, this isn't parallel lines, so it's not the side splitter, but we're told that they are similar triangles, so you want to draw them out. So if I were you, I'd draw these two triangles out, and I think that's going to help make your job easier, because as soon as you say, what's the side of this big triangle, you're going to have to say it's 10 plus x. It's not x, it's not 10, it's 10 plus x. And so these sides are corresponding, and these sides are corresponding. And now we can set up the proportion correctly, which I'm going to go green over yellow and green over yellow. And we can cross multiply. That's 240 equals 160 plus 16x. Subtract 160, and we're going to get, I know I can do it in my head, but when in doubt, type it out. And divide by 16, and we get x equals 5. So, again, draw your triangle out, okay? It's different if it's one of these and we have, the side splitter theorem or the triangle angle bisector theorem. We have different rules for these. This one looks like it's going to fit into one of our rules, but most kids are going to go 10 to 16, x over 24, and you're going to be wrong, okay? There's no parallel lines. Notice these always have to have what? Parallel lines in the side splitter. These aren't told to me to be parallel. They could be, but they're not told. All right. Geometric means. This is where my heart screams with joy. Okay. First things first, remember the parts of the hypotenuse. Okay, so these are the parts of the hypotenuse. They're never used twice. They're always going to be used on the opposite diagonal. So x is used twice, so it gets to be a geometric mean, and y is used twice. It gets to be a geometric mean. And so x is used on the small and the large. So we'll go small and large, and y is used on the medium and the large. Okay, so those two. So what number is associated with the small when it comes to the hypotenuse? Which part? Well, it's going to be the 1. And what about the large? That's the whole thing. So sometimes it's a good idea to come in here and just be like, hey, the whole thing, by the way, it's 10. So we just get that. The medium is 9, the whole is 10. Cross multiply, we get x squared equals 10. So we get the square root of 10. Over here, we're going to get y squared equals 90. And that's going to be 3 red 10, I believe, doing it in my head. And Mr. Smith is on fire. Okay? Bing, bum, boom, dum, dee 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 dee. Okay, isolate that problem. Next problem. Double use. Can't be the hypotenuse parts. Let's just go ahead and put the whole thing in. That's going to be 8. That's the large piece. And we're going to have x is a part of the medium and large. So medium is 6, large is 8. And we're going to do 6 times 8. I think it's 48. Double checking. It is. And take the square root of 48. Let's see. 16, I think, goes into it. So it's probably 4 rad. Does a bigger number go into that? I think it's 4 rad 3. Okay. That was close. Oh, so close. Okay. And then we can set up the y. Kind of running out of room. Put it right down here because we have more space. Y is used twice, and it's a part of the small and the medium. So we're going to use the 2 and the 6. Cross multiply, we get y squared equals 12. Square root, that's going to be 2 rad 3, I believe, because we can pull that 4 out. And there you go. Boom, boom, boom. Used twice here is the 10. Okay, nice. And it's used with the small and medium. So we're going to do 4 and x. Cross multiply, we get 100 equals 4x. X is going to equal, that's convenient, 25, right? 4 quarters and $1, I think. Number 24. Again, let's get that highlighter out. I love the highlighter. makes my life so much easier to get those out of the way. And if I know both numbers, let's go ahead and just add them up and get 20 and 15. Okay, so what's used twice? The x is used twice, so it's my geometric mean. And it's used on the small and the large, so we're going to get 6 and 20. So 6 times 20 is what? 120 x squared. Okay, let's double check that. Okay, and the square root of 120, I don't know that one off the top of my head, but it looks like I can take a 4 out, and that's probably about it. So that's going to be square root of 4 is 2 rad 30. Got a little help on that one. And let's do the y above. No, let's do the y below. We have space below. The space below. Okay, y is used twice. It's used in the small and the medium. I put that line in the wrong spot. There we go. And so small is 6, medium is 14. So 6 times 14 is 84. So 84 equals y squared. Oh, shoot. Take a 4 out maybe? Or I mean a 2 out. Something like that. Square root of 84. It's going to give me 2 rad 21. Boom. Line drawn. Okay. I'm going to skip 25 right now because there's 3 variables, but I'm going to go back to it because I realize 26 has 3 variables. Okay, so this is where we have to be careful here. We're actually pretty safe in this one because we have all these numbers, so we can solve all these pretty fairly actually. So it's just kind of a slow process. I'm not gonna write out small medium, but this is small medium, so it's 3 and 12. And then y is used twice with small and large. Okay, so cross multiply, that's 36. So z is 6. That one's pretty easy. 3 times 15 is 45. So the square root of 45 is going to be, is it, what, 3 rad 5? I think that's it, 3 rad 5. Yeah, 3 rad 5. And last but not least, we have x is part of 2 as well. It's part of the medium 12 and the large 15. Those are 2 largest numbers together. So we get 180 equals x squared. Let's see, I don't know, what is that? 90 times 2 to 45, I don't know. What is that? Square root of 180, I'm using my calculator here, guys. 6 rad 5. I don't want to make this video longer than it has to be. And moving on to our final and most challenging one, which we have to be very careful about. Because here's the problem. I can't do y. I can't use y first because it has to use x. And I can't use z because it has to use x. So I can't use y or z first. I have to use 12. And that's because I want only one variable. And so if I use 12, I have to use 8. And then that's the small. And then the large is x plus 8. That's the large. And so we get x plus 8. So we have to do that one first. So we get 144 equals 8x plus 64. So subtract the 64, we get x equals 10. Okay, so this now makes everything way easier because now we have 10 and 18. We can solve the other ones pretty fast. Okay, so y is going to be with the small medium, so that's 8 and 10. So that's 80 equals y squared. The square root of 80 is 4 rad 5. I feel like I did that one before somewhere. Lose my marbles. And z is used twice. It's in the medium and then the large. So medium 10, large 18. So that's 180 equals z squared, which we did do that one before. And that's 6 rad 5. We did it right over here. Boom. Okay. All right, that's all she wrote. And good luck on the tests and stuff like that. Okay? Name the fruit.